Possible error, also known as permissible error, a very peculiar type. Actually, we come across many types of errors, but on the errors other than this that we are going to study just now, we have a little control. We can either eradicate instrumental error or we can even minimize. But here possible error has some unique nature. This is not the defect or deficiency of the person measuring. This is not the defect of the instrument as well. This is the limit of the instrument, you can say. So here we have to be very positive while studying possible error, also termed as permissible error. We'll start with a circle representing your watch, having the marking for say 12, this is 3, 6, 9 in terms of hours, then 1, 2, further division for second, 1 hand hours hand, I am considering the simplest one. The other hand is minutes hand, and then second hand. Now anybody will read this situation as 12 hours, 5 minutes. But when it comes to second, the situation of second hand is such that you are in a state of dilemma. I mean, you are in dilemma only when you are sincere. If you are in the habit of taking guess, making predictions, then you will proceed. But that's absolutely prohibited. In the process of measurement, there is no scope of any guess. So you can read either. You see, it is here, the second hand is after this 13 seconds. And before this 14 seconds, if you read here 14, you are reading more. If you read here 13, you are reading less. And in between, you are not allowed. So this is the situation when you are seeing the whole thing, you are taking the reading. Here, suppose we say 13 seconds, then one error has taken place here because you are reading less. This error that is taking place without your mistake, that is known as permissible error, that is known as possible error. Suppose the needle hand was this way, suppose the hand was, then you would say there is no error. This is minimum possible error, that means 0. What is the value of minimum possible error? 0. And this is not asked in question. This is not going to be the talk of the topic or your discussion. But maximum possible error that is possible is equal to 1 division. At the maximum, that error which could take place here is equal to 1 division. And what is 1 division? Least count. The smallest division of any scale represents the least count. One very important result we are having, that maximum possible error in any measurement is equal to the least count. Well, we'll proceed with this result. That maximum possible error will be equal to least count itself. And whenever you are studying any formula in this chapter, it's all regarding maximum possible error. Minimum possible error is such a simple thing that everybody knows. It is never topic of the discussion. All the formulas we have mentioned here, obviously it's even not mentioned also, but it is self-understood that these are all the relations for maximum possible error. Now I'll tell you the formula for each expression. For example, say it is sum. Sum means A and B, there are two quantities and A plus B is written there. You want to find the possible error in X. It's going to be the sum of the two. delta A plus delta B, very simple. Similarly, if you want to find the fractional error in x, then what you'll do, delta x upon x, this is delta A upon A plus B and delta B upon A plus B. This you have to remember for solving your problems within no time. Similarly, suppose it is the difference, then in that case delta x is delta A plus delta B. When it was x equal to A plus B, then also it was delta A plus delta B. Then you might think, what's the basic difference in the two? Why it is plus here? Because I told you we are always concerned with maximum possible error, and maximum is possible only by the addition process. So even when there is difference or the minus sign between the two quantities, then also while dealing with possible error and finding maximum possible error, what we do, simply add the error taking place in both. And then in order to find the relative error, this becomes, so this is important to remember. Mostly there goes one common tendency of students, they commit mistake over here. You have to be careful. Now goes product x equal to A dot B. What you'll do, delta x upon x, relative error in x, delta A upon A plus delta B upon B. How to remember this whole thing? You see, this sign, symbol of multiplication was simply converted into addition while dealing with error. Again, I'll repeat it, that if we are finding the relative possible error, we have to convert simply the process of multiplication into addition. And similarly, suppose it is the ratio, or you might call it division, x equal to A upon B. This could be written as AB to the power minus 1. Though power is minus 1 for B, but still it is here the product. You see, I'll repeat this thing. 1 upon B is B to the power minus 1. B is in the denominator, that could be written as B to the power minus 1. Both are equally correct, are equally good. Then you deal this situation simply as an example of product as it was here. This will be delta x upon x equal to delta A upon once again, minus sign, this was not considered. We are dealing with error that is supposed to be always maximum while in discussion. And now what remains is simply the exponent, or you might call it powers on the measured quantities. Say this is alpha A. X raised to the power alpha. And you want to find the relative error in A, then it's going to be alpha delta x upon x. Alpha power, this has been taken as the product. Then how to remember? What will be the remembering technique for you in this example? You need say that the powers are converted into multiplication. Whereas in the case of multiplication, I told you that multiplication process is converted into addition. And here we would say that powers are converted into multiplication.